Beneath the rolling hills and ancient forests of Europe lies a story far older than the ruins of Rome or the stones of Stonehenge. It is a story written not in ink or carvings, but in the very code of life itself, DNA. For centuries, the question has lingered: who were the first Europeans? Were they a single tribe of explorers, a unified people emerging from Africa, or a patchwork of groups who met, mingled, and fought across a frozen, unforgiving land? The bones and tools they left behind told fragments of this tale, but never the whole story. Now, with the help of cutting-edge science, those fragments are coming together. Ancient DNA, preserved for tens of thousands of years, has given us a way to peer directly into the past, revealing a truth far stranger and more complex than we ever imagined. Tonight, we travel deep into that mystery, uncovering the real story of Europe's first inhabitants. If you love exploring the secrets of our shared past, like this video, subscribe to Ancient Secrets, and let us know in the comments where in the world you're watching from. Now, let's begin our journey into deep history. For generations, historians and archaeologists believed the origins of the first Europeans were straightforward. According to this older theory, a single wave of humans left Africa around 50,000 years ago, traveled through the Middle East, and slowly spread across the European continent. These early settlers were seen as small, isolated tribes of hunter-gatherers, adapting to different climates and regions as they expanded. The evidence seemed simple enough: stone tools, cave paintings, and scattered skeletons, all pointing to a gradual, linear story of migration and development. Over time, these groups were thought to have given rise to the later cultures of Europe, laying the foundation for agriculture, cities, and eventually, modern civilization. It was a clean, easy-to-follow narrative, one that fit neatly into textbooks and museum displays. But as scientists began to question long-held assumptions, they discovered that this simple story hid a far more tangled and dramatic reality. The turning point came not from a dramatic archaeological dig, but from something so small it could be held between two fingers: a single ancient tooth. Found in a remote cave in southern Europe, this fragment of human history seemed unremarkable at first glance. Yet inside it lay a time capsule, a microscopic record of a life lived tens of thousands of years ago. Using new techniques, scientists carefully extracted DNA from the tooth. The process was painstaking and exact. Researchers wore full-body suits, working in rooms filtered to remove even the slightest trace of modern contamination. A single modern cell could ruin the entire sample. Once the DNA was isolated, it was amplified and sequenced, creating a map of genetic code that could be compared to both modern populations and other ancient samples. It was like piecing together a jigsaw puzzle with most of the pieces missing, and some so warped by time that they barely fit. What the scientists found changed everything. The genetic evidence showed that Europe's first inhabitants were not a single unified group. Instead, there had been multiple waves of migration, each bringing different peoples with distinct genetic signatures. The earliest wave arrived over 45,000 years ago, descendants of the first humans to leave Africa. These pioneers entered a Europe gripped by the Ice Age, a harsh world of glaciers, towering ice walls, and tundra stretching for miles. They survived by following herds of mammoths and bison, crafting tools from stone and bone, and huddling around fires in caves as the icy winds howled outside. But these first settlers did not last. Over time, their genetic legacy faded, almost entirely replaced by later arrivals who brought new ways of life and new ideas. One of the most striking discoveries came from the analysis of bones found in a cave in modern-day Germany. Deep within layers of undisturbed sediment, scientists uncovered not just human remains, but also tiny fragments of ancient DNA left in the soil itself. This revolutionary technique allowed researchers to detect the presence of people who had lived in the cave, even if their bones had long since turned to dust. The results were astonishing. They revealed a complex, shifting population landscape. Neanderthals had lived there first, followed by modern humans, and perhaps even other unknown human lineages. These groups did not always live peacefully side by side. Some encounters may have ended in conflict, others in cooperation, or even love. The DNA showed that these groups interbred, creating children whose genes we still carry today. Modern Europeans, in fact, still retain traces of Neanderthal DNA, a genetic echo of those ancient meetings. As scientists studied more samples, a new picture emerged. Around 37,000 years ago, another wave of humans entered Europe, this time carrying genetic markers that linked them to populations far to the east. These new arrivals brought different tools and survival strategies. They mixed with the descendants of earlier groups, creating a mosaic of lineages. The blending wasn't uniform. Some regions saw extensive mixing, while others remained more isolated. This created a patchwork of diversity that still shapes Europe's genetic landscape today. During this period, Europe was far from static. Dramatic climate changes forced human groups to migrate, retreat, and return again. When the Ice Age reached its peak, vast glaciers covered northern Europe, pushing humans into southern refuges where the climate was less extreme. When the ice retreated, humans moved back north, recolonizing the land and spreading their genes in the process. This new understanding has profound implications for how we view ancient artifacts. For example, the famous cave paintings in France, stunning depictions of animals and symbols, were once attributed to a single, unified culture. But DNA evidence suggests that multiple groups may have contributed to this artistic legacy. Similarly, the distribution of stone tools across the continent was once seen as proof of isolated, distinct cultures. Now, it appears these tools may reflect the blending of ideas among interconnected communities. In other words, prehistoric Europe was not a collection of separate static tribes. It was a dynamic network of people, ideas, and genes flowing across the landscape. One discovery in particular brought this realization into sharp focus: the skeleton known as the Red Lady of El Miran. Found in a cave in Spain, this young woman lived near the end of the Ice Age, around 19,000 years ago. When scientists analyzed her DNA, they were stunned. It revealed unexpected connections to populations living thousands of kilometers away. This suggested long-distance migration on a scale previously thought impossible. This finding challenged the assumption that Ice Age humans were purely local, moving only short distances within small territories. Instead, it painted a picture of ancient explorers and traders, forging links across vast regions long before the rise of cities or writing. These discoveries also shed light on Europe's myths and legends. Many cultures tell stories of mysterious ancestors arriving from distant lands, bringing knowledge and skills that shape the future. For centuries, these tales were dismissed as symbolic or purely mythical. But ancient DNA has shown that there may be truth hidden in the myths. Perhaps these stories preserve memories of real migrations and encounters, passed down through countless generations and transformed into legend. In this way, science and storytelling come together, each helping us to understand the other. Museums are now rethinking how they present history. A simple stone tool is no longer just an object. It is a clue to a specific lineage, a snapshot of a moment in human evolution. A burial site can now reveal who the buried individuals were related to, how they lived, and how they connected to distant communities. It's as if these silent artifacts have begun to speak, their voices carried through the language of DNA. This shift allows us to see ancient humans not as abstract figures, but as real people with hopes, fears, and families. It makes the distant past feel immediate and personal. The story of Europe's first people is also a story of resilience. Time and again, human populations were challenged by climate shifts, resource scarcity, and competition. Some groups vanished entirely, their genetic signatures fading into silence. Others adapted, survived, and passed their genes on to future generations. Modern Europeans are the descendants of these survivors, the living legacy of countless struggles and triumphs. When we look at our DNA today, we are looking at a record of survival written across tens of thousands of years. As we stand on the threshold of new discoveries, it's clear that many questions remain. Who were the mysterious populations hinted at in the DNA, whose bones we have yet to find? What other secrets lie buried beneath Europe's soil, waiting to be unearthed? Each new find brings us closer to a complete picture, but also opens up new mysteries. The search for answers drives scientists to explore deeper, to refine their techniques, and to keep asking questions about who we are and where we came from. The journey of ancient DNA has shown us that history is never fixed. It is a living, evolving story, shaped by every discovery and every piece of evidence. As you reflect on this tale, consider the connections between past and present. The world we live in today, diverse, interconnected, constantly changing, is the result of patterns set in motion tens of thousands of years ago. If this exploration has fascinated you, please like this video, subscribe to Ancient Secrets, and share your thoughts in the comments. Which part of the story surprised you the most? And what do you hope we uncover next? Together, we'll continue to reveal the incredible story of humanity, written in the ancient code that lives within us all. These discoveries remind us that the story of humanity is vast and still unfolding. Every excavation, every piece of DNA adds another chapter to our shared past. Imagine the countless stories buried beneath our feet, waiting to be told. Ancient DNA has given those silent voices a way to speak again. The first Europeans were more than just survivors. They were explorers, innovators, and dreamers who shaped the foundation of modern civilization. Their legacy lives on in us today. By studying their DNA, we understand not only where we came from, but also where we might be going. Science and history together can unlock the mysteries of our species. And with each breakthrough, we take another step toward uncovering the truth of our origins. The journey is far from over. More secrets lie hidden beneath layers of earth and time. Ancient DNA is the key that unlocks those layers, one discovery at a time. And through it, we reconnect with those who came before us. The story of the first Europeans is ultimately the story of us all. We are all part of a vast, unbroken chain, stretching back through the ages. Each of us carries a fragment of that ancient past within our own bodies. It's a connection both humbling and inspiring. The more we learn, the deeper our understanding of what it truly means to be human. The journey continues, and with it, the endless quest to uncover the secrets of our shared history.